Okay, so today is lesson 12.6, the volume and surface area of spheres. And so we have talked about the volume and the surface area of, um, let me see, of prisms and pyramids. And we also have talked about the volume and surface area of cones and um, I forgot what I just said. Pyramids, prisms, cones, and now it's time for the curvy shape. So again, my list is not the best, but let's look at what we're going to do today. So spheres and hemispheres. Those are the main things today. So you can look back at your last couple lessons. We've done a lot of surface area and volume. Um, but if you want to talk about a sphere is basically a circle that's 3D. And if you start with a point in the middle and you draw not just a circle, but a sphere and going all the directions all the way around, that is going to be a sphere. And the radius is the distance from the center to any point on that sphere, that 3D shape. A hemisphere would be half of a sphere, okay? And then here's something that's big, and I think it's on your test too. Like what is a great circle? Well, if you slice open a sphere, so like you slice open an orange, you could slice an orange at many levels, like at the top and like kind of down a little bit. If you slice it in the middle, okay, the great circle is the biggest circle when you make a cross section, okay? So that would be a great circle. And there's many great circles you could cut, doing cross sections, depending how you cut the apple or the circle or the orange or whatever. But the great circle is the largest circle that you could do as a cross section. And so you could get it by slicing exactly through the middle, horizontally or vertically. But the great circle is the biggest circle that you could get with a cross section of a sphere. And so surface area is how many square units it takes to cover the surface of a figure. And so there's a formula for that. It's 4 times pi r squared. Okay, so that's going to be a good thing. And then the surface area of a hemisphere, you may want to find the entire surface area of a hemisphere. And a hemisphere would be like the lateral portion, okay? And that would be this part right here. It would be basically this 4 pi r squared and then be half of it. So you could reduce that to be 2 pi r squared. That's going to be the lateral. Okay. But if you actually cut it open and you're talking about how much is exposed of that figure, you could add on the circle. Okay, so it could be also including this. Depending what figure you've got, they may just be like, how much is just the external part of this? Like if you're talking about how much peel is on half of an orange, well, you would just do this first 2 pi r squared. If you want the whole surface area, once you have a hemisphere, it'd be the lateral part, which is that first part of the formula. And then you'd also add on that circular part, which is going to be the exposed middle of that figure. Now, if you combine like terms and you want the whole thing, you would do 3 times pi r squared. Okay, so that would be the lateral, which is that bottom part plus that circle. So depending if you need part or whole, you could do just this first portion, which would be 2 pi r squared. That's the lateral. You could just do the circle, which is pi r squared, or if you put them together, you would get 3 pi r squared. So um, and then the whole sphere's surface area is 4 pi r squared. So it's kind of cute. Circle is pi r squared. The outer part of half a circle is 2. And then the whole thing would be the hemisphere, the whole thing, a hemisphere is 3. And then the whole sphere is 4. So I don't know. It gets bigger and bigger the more surface area you've got. Volume of a sphere would be a 4/3 times pi r cubed. That's how many 3D cubes can fit within a figure. And a hemisphere is pretty easy. It's just half of that. Okay, so the volume of a hemisphere is going to be half the volume of an entire sphere with the same radius. So a lot of logic here. So how would you do this first figure? It says find the volume So the volume is 4/3 pi r cubed, and it's a whole sphere. The radius is 9. Okay, and so you can take that in your calculator. I would use the fraction key. Okay, if you don't have a fraction key, I would do 4 times pi times 9 cubed, and then push equal, and then I would push divide by 3. Okay, you could put it all in parentheses. If you have a graphing calculator, you can put this whole thing in here. The answer to it, okay, and see if you can get this, is 3053.63 centimeters cubed. Okay. So another way to look at it would be 4 pi r or 9 cubed. And then over 3. Okay, that'd be another way to put it in your calculator if you want to. So if you got the fraction option, any of those, if you type it in right, should give you this. So you can check it and see. If you need help, holler. Next thing would be, what if I say, give me the diameter if I know the volume? You're like, oh, you're me. Yeah, volume equals 4/3 pi r cubed. Okay, so let's find it. So if you know the volume is this, so that goes right here for V. They have a pi in it, so that's going to be easy for us. If it didn't, you'd have to divide both sides by pi and use your calculator. So in this case right here, we can divide both sides by pi, okay? And then to get rid of the 4/3, we are going to times both sides by the reciprocal of that fraction, which is 3/4. What do you mean? Well, if you have 4/3, and if you times it by 3/4, you get 12 over 12, which is just 1. Okay, so if you want to get rid of a fraction, you can times both sides by its reciprocal, okay? And so 3/4 times 2304 is going to give us 1728 equals r cubed. Now here we're going to have to use take the cube root of it, and I want to show you that on my calculator. The cube root is in math, so go to math. Okay, yes, there's a math button. It's on the left. It's highlighted red right now, so hit math. And option 4 is cube root. So I can type 4. So I hit math, which is on the left, okay, below alpha. So we do option 4, which is cube root. And the cube root of 1728 is going to be 12. And that would be centimeters. Okay, so that's a good question for us. Okay, lots of reasons. Can we work backwards? Can we get rid of a fractional coefficient by multiplying by its reciprocal? And then can we take the cube root? Find the volume of a sphere, a volume of a sphere. If the what's a great circle? The great circle is if you have a sphere and you look at the largest cross section you can cut. Okay, it's right through the middle. The circumference of that is 22 pi. Well, the circumference is going to have a radius, okay? And the radius of that will coincide with the radius of the overall sphere, okay? Because we're doing the biggest circle, the great circle. So if we've got circumference equals pi d, and they give us the circumference is 22 pi. Okay, to solve that, you're going to divide both sides by pi. D equals 22. That means the radius equals 11 centimeters. Okay. Oh, the top one, they want us to find the diameter. So let's times that by 2 and you get 24 centimeters. Okay, that would be our final answer on the top one. The next one, it says, give me the volume of the sphere. Well, if you know the radius, the volume of the sphere is going to be 4/3 pi r cubed. So it'd be 4/3 times pi times 11 cubed. Get that in your calculator, and you're going to get the volume to be 5575.28 centimeters cubed. You should try it, see if it works. Okay, make sure you know how to use your calc. If you had a graphing calc, you would use the fraction case. So 4/3 times pi times, and that would not be pi squared, pi cubed. It would be 11. Okay, there you go. This says find volume. Okay. I don't think we've found surface area yet. Okay, so actually we did find the surface area. Found the surface area. Oh, we did not. Right here. I skipped 2 questions. Go back here. Okay, find the surface area. So the surface area is equal to, of the whole sphere, is going to be 4 pi r squared. Okay, so that's from here. The whole sphere is 4 pi r squared. So 4 times pi times 2 squared. If you want that in your calc, you get 50.27 feet squared. That's the surface area of that figure. The surface area of this one looks like they want us to find the entire surface area. So we're going to do 3 pi r squared. It's right here. So 3 pi times 5 squared gives us 235.62 feet squared. I thought we might have missed that. Okay. So that's how you find surface area. 4 pi r squared or 3 pi r squared, or depending if you want the different pieces of the surface area. Again, only the outer portion of this half circle would be 2 pi r squared. The circular cross section, the great circle, is going to be pi r squared, but together, if you want the whole shebang of that hemisphere, you want 3 pi r squared. If you want the entire sphere outside, it's going to be 4 pi r squared. Okay, now back to here. Let's do volume. Volume equals 4/3 pi r cubed, 4/3, and it says in terms of pi, and then round it, okay? So 4/3 pi, and this would be 2 cubed. So in our calculator, if you want it in terms of pi, you just do the numbers. I'll show you how to do that. I would do alpha 1 equals enter. I would do 4/3, arrow to the right, times 2 to the third is 32/3 pi. And that is feet cubed. And then if you take that answer and times it by pi, you're going to get 33.51, and that would be feet cubed. Okay. So just, if you want it in terms of pi, just times the numbers and want pi right after it. And then this, they want the hemisphere. So the volume of a hemisphere, okay, is going to be 1/2 of the volume of a whole cube, a whole sphere. So half of the whole sphere. So if you do this, you do 1/2 times 4/3 times pi times 5 cubed. Okay, so you can use your calculator. Alpha y equals enter. 1/2 times 4/3 times pi times 5 to the third is 261.799 is 0.8, and that's in feet cubed. And if you want to do it in terms of pi, which is that's what they want, you just type those 2 numbers and this and put it in front of pi. So this would be alpha y equals enter 1/2 times alpha y equals enter 4/3, and then we got times, oh whoops, that did not work. You know what I'm going to do? I'm going to arrow up here. What I'm going to do is grab that, and I'm going to just delete the pi. Here we go. This is going to be 250 over 3 pi, and that would be feet cubed. Okay. We've got one last question. It says, give me the overall volume. This is called composite. When you're trying to find a volume of a figure that you either add or subtract multiple pieces to each other or from each other. So if we find the volume at the top, That's the volume of the top is equal to 1/3 area of the base times by the height. And the base in this case is going to be a circle, and the height is going to be this length right here. So 1/3 area of that base, which is 21 squared pi. The height, it looks like this total distance is 71 or 70. This part right here is 35. And so that means the height here will also be 35. Plus, okay, that's going to be the top cone. Then we got to find the volume of the cylinder in the middle. That was going to be the area of the base, which is a circle, okay, and times by the height. And the height there is 35. The area of the base would be 21 squared pi. And then we're going to do the area of the bottom is going to be 1/3. And the area of the circle, this part here, 21 squared pi. And then the height, and the height here is going to be, it looks like 40. So if I want to type the first one in calculator, I'm going to get 16163.49. The second one is going to be 48490.48. And the last one is 18472.56. The overall volume is 831.26.54 centimeters cubed. All right, thank you so much. I hope you have a great day.